DC. Okay, first one here. Got 32. Well. Okay, one way I like to solve this. Wait, let's read first. So the figure is made of a trapezium. We have a trapezium BCDF. BCDF. Right angle triangle AED. Yep. DF, AEF are isosceles. Where's D? DEF. Okay. BOC is equilateral. Where's BOC? Okay, so for questions like that, I like to write out all the known angles first, okay? That means I try to write out, because when we look at this, we cannot tell a lot of stuff, okay? So there are some additional information that we should put in first. So this is equilateral, that means here 60, here 60, here also 60, right? Isosceles here is 63. Yes, isosceles. 180 minus 110, we have 70 here. 70, 180. Now, if these two are 63, I'm just looking at this one. These two are 63, so I can find this first. So I just take 180 minus 63 minus 63. This method is called write out all angles first. This is 54. If I know that's 54, I can find this as well. How do we find that? Just 360 minus 54 minus 70. 236. I don't know if I need this, but it's easy to find, right? So I just write. I'm just writing out everything first. Okay, whatever I can find. Wait, where is 20? Oh, this is 22. This is 22. Okay, 22 over there. This is 70. Oopsie. 70. Okay, what else can I find? I can find this as well, right? Because, wait, how can it be 236? Something wrong. 54, 180, 70. There's something wrong there. Wait, calculation error. One, 2, 6. It's 1, 2, 6. Okay, so I can find the other small angles. 180 minus 1, 2, 6 divided by 2. This is 27, 27. Okay, so what I'm doing is I'm just writing out whatever I know without looking or finding out other stuff. Okay, so first one, find angle FDC. So FDC, okay, how do I find that? FDC, 60. 22 minus. Okay, 70, 60. What else can I find? This is, okay, this is parallel. Oops. Parallel. Okay, if this is parallel, that means I know this angle. Right? How do I find this angle? It's called interior angle. There you find AFE. Okay, wait. So interior angle. So here's 70. Here must be 110. So if this is 110, I have to take 110 minus 60. This will be 50. 50 degrees. And what else can I find? Now, if this is 22, basically I can find the first one, FDC. So FDC is 360, take away 70, 70 minus 110 minus 82 equals to 98. Okay, so what am I doing here? What am I doing here? 360, where's 360? Yeah, also can. Also can, right? So 360 is the whole thing. I'm replying that your Tridio is messaging me. So this whole thing is actually 360 degrees. So this, but 360 degrees consists of 1, 2, 3, 4. 4 sides, right? So I take 360 minus this one, minus this one, minus this one, I get this, right? So Tadio suggests why not take 180 minus this, you get this, also can, right? That's actually faster, more straightforward. Huh? So 180 take away 82, you get 98. So this one is 98. Very good. Everyone is thinking, right? Next, EFB. Where's EFB? Where's E? E, F, B. So just add the two. 54 plus 70. Is it okay? 54 plus 70. So EFB EFB 54 plus 70. That will give us calculator time 124. That's it. Next, any questions for this? Nope, everyone okay? Everybody okay? Next. Okay, next is here. Okay, Derek's shop sells shirts and pants. So on Friday, Derek sold 2/3 of the clothing, I corrected 362, or 2/3 of the clothing sold were pants. How many shirts did Derek sell? Okay, so let's find the price of a pair of pants first. Now, because the pants is 48 and the shirt is 3/4 the price of a pants. Step one, 3/4 times $48. I think we get 36, right? 12, yeah, it's $36. So the pair of pants is $36. Okay, so Derek sold 2/3 of the clothing and collected 3672. 2/5 of the clothing to what? Shirts and pants. How come there's clothing? Collected 3672. Oh, clothing means general shirts and pants. Honestly, I didn't know that. Right? I thought clothing means what you wear on your upper body. Okay, so the clothing is referring to everything. Okay, so there is so 2/3 of the clothing collected. 2/5 of the clothing were pants. So we can draw a diagram. Right? How many shirts did he sell? Okay, so this is pants. Pants is $36, right? And then the shirt Hey, what? Sorry, shirt is $36. Shirt. And pants is $48. This looks like what do you call that? Value and units question. A rule question. This Isaac, do you solve this using rule? Then how do you solve this? Model drawing. Imagination. Guess and check. Guess and check. Okay, guess and check, fine. Okay, I need more space. It's a rule question. What do you mean by rule? So we have value. We have the value of shirt, which is 36, and pants, that is 48. We have the units. Okay, so what's the units? 2, 5. 2 of the clothing were pants. So this 2 unit, 2 out of 5. This is 3 units. Okay, so value unit question must find rule. How to find rule? You multiply, okay? So 36 times 3, random guess. Okay, 36 times 3, 108. Okay, not money, huh? This is 108 VU. 48 times 2, 96 VU. Okay, so add them together. 108 plus 96, 204. So 204 VU represents 3672. Right, so 1 VU, it's 3672 divided by 204, $18. Now, if 1 VU is $18, how much is 108 times 108? 1000. Okay, not enough space. Phew. So over here is 1944, and over here 6 times 18, 1728. Okay, so that's the value of pants and shirts. So the question is, how many shirts did Derek sell? They want shirts. So shirts cost $36 per shirt. He sold a total of 1944. So to answer part A, we take 1944 divided by $36, which will give us 54 shirts. Okay, so this method you don't have to use guess and check. You will get it directly, right? You also don't have to do random guess. So how many clothing were left unsold in the shop after Friday? So the next thing we need to do is to actually find how many pants were sold as well. So for part B, the number of pants sold is 1728 divided by $48 per pants. $48 per pants is quite cheap nowadays. It's 36. So I'm going to use this space here to continue. So what is the total item sold? Total number of items sold is 36 and 54, which if we add them together, 36 plus 54, 90. 36 plus 54 equals to 90. So 90 items were sold. And this 90 items is equivalent to 2/3 of the clothing, which How many is left unsold? Very good. 45. Okay. So 90 divided by 2 equals to 45. Okay, or you can take 18 times 5 divided by 2. Final answer. Okay, so what method do we use to solve this? VU, which is my favorite method. Because VU sounds so nice. VU. Questions for this? Any questions? What are you doing, Isaac? Why are you shining torchlight in our face? Isaac, why are you shining torchlight in our face?
Can you like scroll up? Because I can't.
Sure. Yes, let's go on. But why is Isaac shining torchlight in my face? I can see the torchlight. You can see the blue light. Luckily, I'm wearing the Blu-ray spectacles. My Blu-ray spectacles reflect all blue color light. Okay, so it doesn't
If
damage
it
my eyes.
reflects blue color light, how can you see that it's blue?
I don't. You see, I show you, right? Can you see? Isaac can shine, right? But all the blue is being reflected away. Can you see that? This Isaac, whole thing blue. Okay, so all the blue come, then will go back. Okay, so yeah, let's go. Is it okay already, Samuel? How
Yeah.
come the star change now? Become Samuel got 1 star and can I change position or something? Next. That's 5 marks. Suppose this very wordy. Okay, let's see this. I didn't put a star. That means someone got this correct. Who got this correct? Is it Isaac? Yeah, I think Isaac got this correct.
100% cannot be me.
100% cannot do.
Cannot be me.
Yeah, no. Okay, so let's take a look at this. So there were 1,375 adults at the conference. The ratio of number of women still is 3. Okay, before and after, right? Before and after. Okay, I'm gonna need a lot of space for this. Scroll down. I think it's new 100%. Isaac says. Yes, it is. It is before and after, and then after that you get a new 100%. So your units before and after and the 100% before and after are all different, right? So you cannot be using the same 100% to refer to the same thing. Okay, let's take a look. Now what I like to do is I like to break it up into different parts, okay? So the first part, I'm gonna use a box. Draw out to 3. Okay, let's draw that first. How many women? How many men? Right, so 1,375 women and men. So we take 1375 divided by 5. 1375 divided by 5 times 2. So that's 550 women. 835 men. Okay? That is the first box, right? Based on the first box. So after an hour, 40% of the women left. Let's look at the next box. 40%, oops. 40% of the women left. So we want to solve this 40%. So what's 40% of 550? So 550 times 0.4, that's 220. So left how many? If you take 550 minus 220, you get, 330. Right? Then 2 hours later, 20% of the remaining women left again. So minus 20%. So 330 times 0.2 minus 66. Wait, the first one. Second one, 330 minus 66. It's 264. Okay, so to answer part A, how many women stayed on in the conference? This is part A. It's just 64. What's 64? 264. Simple? Pretty simple. Now to answer part B, I'm going to use blue. What percentage of the people who stayed were women? So we have 264 left. Now, did any men leave the conference? Did any man leave the conference? No, right? They stayed throughout the entire conference. So for part B, the total, right? What's the total number of people now? We got 825 plus 264. That would be equal to 825 plus 264. 1089. Okay, so we want the percentage who stay with women, 264 over 1089 times 100%. That's 100. Okay, we got this 24.2. Right, correct with 1 decimal place. That is all. Not too bad, I think. Okay. Any questions on this? Very good. Tell you, I like the way you're typing out all the answers and the working. Give you 1 star. Ooh, wait, where's my star? Whee! Okay. Hey, wait. How come the star becomes Samuel? Wait, let me see. Erase. So 2 stars for doing. Okay, if you are done, I will move on, right? Samuel, are you done with this?
Yeah.
Okay, good. Moving on. Okay, so this is the one that everyone got wrong. I used to like cookies a lot until I realized that a lot of the PSLE math problem sums, right, always evolve around baking cookies and brownies and all this stuff. So every time I look at cookies, right, it reminds me of a math problem sum. And then I eat less cookie, right? So now what do I eat? I eat peanuts, you see? I eat peanuts because there isn't a PSLE math problem sum about peanuts so far. There's a lot of cookies, okay? So let's take a look at this question. First off, what kind of question is this? Hey, let me read. So Mr. Lee baked some cookie, morning, 1/4 cookie, received 9 free, the afternoon, bought 1/3 remaining. Remainder concept. Remainder concept, okay? But this is a advanced, slightly more difficult remainder concept because it involves additional free cookies. So I'm going to need some space to draw the model, okay? I'm going to use model drawing to solve this question. Let's draw a model. So Mr. Lee baked some cookies. Jason bought 1/4 of the cookies and received 9 cookies free. I'm going to draw a box first. Let's use a rectangle tool. Okay, so Jason bought 1/4. Now, if it's 1/4, it means I'm going to break it up into several groups. 4 groups to be exact, okay? So draw a line here, draw a line here, draw a line here. Okay, so Jason bought 1/4. This one, that's 1/4, but there's an additional 9. So where's the additional 9? I'm gonna use another color. Maybe green. Plus 9. That's bought by Jason. Okay, Jason bought this. J for Jason. 1/4 plus 9. So what's left? Whoa, 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 whoa. Whoa, 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 whoa. How come so many messages? Oh, you already finished everything. Okay. Wait. Let me go with the model drawing diagram first. Okay, then in the afternoon, Adam bought 1/3 of the remaining. So what I want to do is I want to do a drop down remainder. Drop down remainder. Where's the drop down remainder? It's from here to here. So this is my drop down remainder. Okay, drop it down, drop it down. This is my drop down remainder. Now for the remainder, Adam bought 1/3, which means I need to break it up into 3. So like that, right? Adam bought 1/3, 1/3 plus 2 free. Okay, he got 2 free. Then Mr. Lee had 1/8. So what happened to this 1/8? I gotta drop down again. So this is a triple drop down remainder concept. Okay, so oops, sorry. The leftover is here. Triple drop down from here to here is the triple drop down. So here and here, right? So this third drop down is 1/8. Very good. Teddy already have the answer. It's 1/8. Okay, so can you see that? Usually remainder concept drop down 1 time and then you solve. But now they drop 2 times. So when you drop 2 times, sometimes you go haywire. You go like, oh, what's going on? But you just need to follow the story, right? You just need to follow the story and just draw your drop down remainder. It's fine. Okay, so what do we do next? So how many cookies did Mr. Lee bake? Now to find the first answer, we need to start to work backwards, okay? Why? Because you see there's 1/8 plus 2. 1/8 plus 2 is equals to 2 red color units. So step 1, 118 plus 2 equals 120. 120 equals to 2 rate units. So I take 120 divided by 2 equals to 60. Okay, it means one red color is 60. I'm going to use a red color. One red color is 60. Okay, which means here is 58. Right? So 58, 60. Right? So next thing that I do is I take 60 times 3. That will give me 180. Then 180, now we go to blue. 180 plus 9 equals 189. And 189 got to divide it by 3. That will give us 63. So one box here is 63. Right? Now the question is, how many did Mr. Lee bake? Mr. Lee had 1, 2, 3, 4. 4 of that. So 63 times 4, 252. One answer. Questions for this. Drop down 2 times. Right, a bit tough. But it's still a drop down remainder. Tadio has 38 more minutes, Isaac. Me news. 38 more me news. Me news. Okay, so first one, 252 people. We'll go to the next one. In the evening, Mr. Lee put up the sign as shown. He sold all 118 cookies in the evening. What was the least amount he earned that evening? So one cookie, $1.50, buy 6, get 3 free. Okay, we got to divide by 6 first, right? Divided by 9. Oh yeah, divide by 9. Very good. Because each packet comes with 9 cookies. It's 9, okay? Because 6 plus 3 equals 9. Tadio. Got a question for you.
Yes.
Okay. Do you like the soft math questions?
Of course.
Of course, right? So I realize you are getting a lot of them correct. Okay, I think you should do more difficult ones. Okay. Okay, I think you are getting a lot of them correct, because the way I see you solve math, right? You can do difficult questions. Are you in the gifted class or something?
No.
Program. You should give it a try, okay? I think you do okay. So it's 9, right? 6 plus 3 equals 9. I wasn't in the gifted program when I was young. Anyone else in the gifted program? It's no? How about Isaac? No? But you know what? No, we are all gifted. Why? We're gifted with our own abilities, right? Like everyone has got their own ability. Like Isaac is gifted with the ability to type very fast. Okay, Samuel is gifted with hair on his head.
What?
Yeah, Samuel got hair. All of you got hair on your head, right? You see, mine is dropping already. I'm not gifted with hair. Okay, but I am gifted with a nice set of teeth. You see, yeah, which I brush every 2 times a day. Anyway, let's continue. Wait, what? Oh, okay. Daniel type out the answer again. Okay, so now how do we solve the second part? Sorry, I got carried away a bit. Now for the second part, we know that one packet like that, right, has got nine cookies. Okay, one packet 9. So Mr. Lee left with 118. So we want to find out how many packets of 9 are there. So what we do is we take 118 divided by 9 divided by 9. We will get something with a remainder. 13 remainder one. Wow, thank you, Daniel, for all the working. So we get 13 remainder 1. So this additional 1 cookie will be sold for $1.50. 13 packets. 1 cookie 150, buy 6, get 3 free. So we got to take $1.50 times 6, which will give us $9. Okay, because one packet like that costs $9. Right? Okay, I'm looking at your working. 38 plus 13 packets. 1 cookie 150, buy 6, get 3 free. So each one costs $9. So 9, we bought 13 packets. Okay, so if we take $9 times 13, we get 117. Okay, and then remember we have the remainder 1. So the additional 1 cookie is $1.50. So we can then take 117 plus $1.50. Get 118.50. Okay, all the way to the edge. Let's come here. That is the final question. Final answer. Why 9 times 13? That's a good question from Isaac. Now, one packet of this, he will earn $9. How come? Because buy 6, right? Each one is 150. So 6 times 150 will be $9. $9. So one packet costs $9. So he sold 13 packet. How do we know 13? Because here is 13. He has 118 cookies and he's able to get 13 packets of this. But there's one extra cookie which he cannot pack inside the packet. So either he eat or he sell. But he can't eat them, right? Why? Because he sell cookies. He's been selling cookies for 50 years. I'm sure he has eaten a lot of his own cookie. So he doesn't want to eat any more of his own cookie. So he will sell the remainder cookie. My neighbor makes cake. Like, it's a shop, right? She has a shop. So she always gives us cake. But I never see her eat her own cake. Do you know why?
sell all of it?
Huh? What?
Is it she sell all of it?
Yeah, she sells all of it, right? But because she's been eating her own cake for maybe 50 years, she already know how it tastes like, so she doesn't want to eat anymore. But she's happy that other people like her cake, so she give me free cake. I get free cake. To be exact, is banana cake. Her banana cake is ultimate.
Is it good?
It's very, very good. Banana cake. Okay, are we okay? We got one last question to go, then we can go on to the next paper. Ready? I'm gonna pop one peanut while waiting for Samuel. Peanut time.
Okay.
Alright.
Yeah.
Next. Okay, find the parameter of the remaining figure. So this is the one that Daniel got calculation error, right? I told you. You almost got it correct. Okay, some calculation. This one Isaac, correct, right? Huh? No. Yeah, I thought someone got it correct. Sorry. Who got this correct? Isaac, I thought Isaac got it correct. So tiny error somewhere, right? So a quadrant and semicircle are cut. So this has got to do with our advanced circle questions. Big quadrant. Find the parameter of the remaining figure. So where's the parameter of the remaining figure? It is here, all the way here, down like that, then curl inside. Okay. Whoa, Daniel, did you just type out everything again? It's one big lump of answer. Okay. So the answer is 129.08. Let me check. Not correct, right? Yeah. Try again. Try harder. It's not 129.08. Okay, let's do part by part, right? We do bit by bit. So here is, okay, let's find this quadrant first. What is the length of this quadrant? Now for this quadrant, the radius is 40. Radius 40, right? Quadrant. So this is going to be tedious, okay? Let's write down everything slowly. So 1/4 times pi, 2 pi r. What's pi? 3.14 times 40. Okay, so we divide. We times 2 times 3.14. 62.8. And let's label it. So 62.8. Yep. Okay, so that curve 62.8. Next. 20. Okay, so here is 20 as well. Can label this. Next, let's find the inside curve. Where is the inside curve? This one. Inside curve is here. Here to here. All right, so the inside quadrant, I have to use 20 cm as the radius. So it's 1/4 times 2 times pi times 20. 2 pi r. $31.4. Yeah. So 31.4. Okay, that curve is 31.4. Next, I want to find the semicircle. This is the semicircle. Now to find the semicircle, what is the radius? It's 10, right? It's 10. Okay, the radius is 10. So now it's a semicircle. So it's half times 2 times pi times 10. Let's find the semicircle. So 3.14 is 10. 31.4. Okay, so this semicircle it's 31.4. Okay, use another color. 30. Finally. 145. 24. Who is 25 more minutes? I have no idea who's that. Okay, so 31.4. Okay, now we add everything because we need to find the parameter. Okay, so let's use our calculators. 2.8 plus 40 plus 20 plus 31.4 plus 31.4. Okay, so if you add all the parts together, you get 185.6. Final answer. Wait, 62.8 plus 40 plus 20 plus 31.4. Okay. Yeah, 185.6 centimeters. So we do slowly. This one is take our time to do. You see that? Because there are so many numbers involved, there's so many different radius and pi decimal place. Take our time. Yeah, that is correct. 25 more minutes. Sorry. 25 more minutes is wrong. Next, find the area. Oh my god. How many marks is this? The marks better be worth it. 3 and 2. My god. 3 marks, 2 marks. Okay, tedious, a bit tedious. Right, but never mind. The marks are definitely worth it. Okay, do you think the marks are worth it, Isaac? No. Daniel, do you think the marks are worth it? For 3 marks? Huh? Samuel? Do you think the marks are worth it? No, 3 marks are so much working. I think it's fine. It's not too bad. Stadio is typing something. The marks are worth it. Yes, I also think the marks are worth it. Okay. All right. So next, the next question is only 2 marks. To find the area of the remaining figure. Now, for you to find the remaining figure, the strategy is to take the big one minus the small one. Okay. There's a big quadrant. take away this two big one minus this two, you get the rest. So I'm going to do it working over here, okay? So let's find the area of the big quadrant. So area of big quadrant, we're going to use red color. It's 1/4 times pi times r squared. So the radius is 40. Pi r squared. One, 2, 5, 6 cm squared. Okay, so this is the big quadrant. Next, small quadrant. Three, 1, 4. Okay, so that's a small quadrant. And the semicircle, half times pi and square. One, 157 cm squared. Next, to find the area of the remaining one, right? 1, 2, 5, 6 minus 3, 1, 4, 5, 7. $785, yes. Oops. That is the final answer. Oh my god. Look at all these math problem sounds.
Finally.
Yeah, finally. Very tedious, right? How many lines are working? 1, 2, 3, 4, 5, 6, 7, 8. 8 lines for 5 marks. Can I think can worth it, worth it. I will do it, right? I'll do it, right? For 5 marks, yes. Okay, I will totally do this. And let's give ourselves a star. Ooh.
Could have done that later.
Why? You're copying halfway.
Yeah.
Hey, the all star come already. Okay, copy first. We're gonna go to the next question. The next paper is going to be multiple choice. So multiple choice means you can do on the spot with me. Okay. So please copy this first. Who's that so busy starring the whole book?